So next session is Irving Rodriguez from Essemtec. In fact, I'll let Irving introduce himself. Thank you.
Yes, so my name is Irving Rodriguez. We're going to talk today about something that everybody have to do in the production for electronics, which is repair or enhancement. And before I jump into the agenda, I will show you the company where we come from. The whole work was made at Essemtec, the company in the corner, and we belong to a bigger concern called Nano Dimension. Nano Dimension is one of the leaders in additive manufacturing, with several companies under his umbrella, like Atmatec, Global Inkjet System, Fabrica Group, etc. And Essemtec, we are a provider of solutions for the SMT industry. So we provide every type of solution, like printed electronics or manufacturing of printed electronics, complex volume repair, high-speed dispensing, etc. Okay, so now the agenda. Why repair? We're going to discuss why, what are the reasons for repair, current repair methods for electronics, proposed repair method, the one that we are proposing, we have already several customers with it, case studies, and conclusions. Okay. So why repair? This is a very nasty picture that could be everywhere in the world. Could be here in Europe, it could be somewhere else. And basically, we are throwing away 140,000 tons of pure electronics, every single day. And you can imagine with the IoT, Internet of Things, connecting smart components, this number is going to increase dramatically every single year or day. And just to put this value into perspective and to make it a little bit more personal, this means that we are throwing away every day the weight of 622 statues of the Liberty. And this is, at a personal level, we are throwing away about 6 to 8 kilograms of pure electronics every single year, so per person. So you can do your math, everybody come more or less to this number in average. Okay? Another reasons, just put it down into not on the environment, but more on the production floor, is placement of wrong components with wrong orientation, and counterfeiting parts. This is also a big issue. Another thing is we need to keep in mind is the circular economy. There is a big movement in several years, especially in Europe, for a circular economy, which basically means we need to use our products, especially electronics, as much as we can. So that means we need to enhance the current products, we need to prolong the lifespan of the products, and if possible, design that we can reintroduce these materials to the environment without too much damage. Okay. So current repair methods. So basically, this is a very rough say the steps for repair. You need to remove your component, desoldering your component. You need to apply solder paste, component placement, and then reflow. And basically, our solution helps you with applying solder paste and component placement. Especially the smaller the pitch, the more difficult it will be to repair, the more our solution will help you with your challenge. Okay. This is one of the traditional methods. So let's say you have a product with a lot of components. You have to repair a BGA. So you come there, you put a stencil, and then you need an operator which is quite good doing that. The reliability is not very good. You can only repair one component at a time. And this consumes a lot of time and also a lot of money. And the reliability is also not very good for this type of methodologies. The proposed repair method, that is our machines, our instrument. We have a table here in the corner. Basically, it's a machine that you can use for production. And with this one, you can do instead of stencil printing, you can do solder jetting. You give you Gerber files, and the machine recognizes where to put the dots at a very high speed. You can do also glue, so applying of glue jetting, and do pick and place with the same instrument, including components. So pick and place of components and inspection. And those are the components here: solder jetting, flux jetting, and pick and place. So I have one video